All right, here are quiz 7 solutions. We're asked to make a bunch of confidence intervals. In this first one, what we're talking about hot wing consumption. When we're told that the standard deviation is 10. And what's important to know is that that's sigma, because it's standard deviation for all Americans. And that n looks like is equal to 50. And in this sample of 50, the average is 24. So x bar is 24. And what it wants is a 90% confidence interval, so alpha is 10%. Okay, so let's see here. My shape is approximately normal. And that's because n is greater than or equal to 30. And it is a z distribution because sigma is known. My center is my point estimate, x bar, which in this case is 24. And my spread is sigma divided by the square root of n. Sigma in this case is 10, n is 50. So I got to figure out 10 divided by the square root of 50. Alright, so I calculated that standard deviation, and now what I can do is kind of draw a little picture of my confidence interval. Not a great picture, but it'll work. I want 90% of the data in the middle. That tells me that I need 5% out here and 5% out here, so what I need to figure out is z sub 0.05. You look those up in your tables or calculator or whatever, and you get that that's 1.645. So what your confidence interval is x bar 24 plus or minus 1.645 of these standard deviations, these 1.41s. If you multiply 1.645 times our standard deviation, yeah, 2.33 maybe we'll call it. Maybe I'll say equals 24 plus or minus, what did I say, 2.33? 24 minus 2.33 is 21.67. 24 plus 2.33 is 26.33. So there's my confidence interval. All right. This second problem looks pretty darn close to the first one. I think the only thing that is different is now the standard deviation of 10 is corresponding with our sample. So what I'm trying to get at here is the one relevant difference is now it's that s equals 10. N is still 50, x bar is still 24, alpha is still 0.10. So a lot of this stuff is the same. We're still approximately normal. For the same reason, because n is still greater than or equal to 30. But now it's a t distribution because sigma is unknown. Center, same. Still just x bar, which is 24. Spread, same. Still just the standard deviation divided by the square root of n. And since s is also 10, what I get is still 1.41. What will change, maybe I'll slide this over a little bit, is in my little picture here, I still got 90% in the middle, means I still got 5% out here, but it's now a t value I want over here. So maybe I'll add one more row over here. I could say degrees of freedom are 49. And if you go to your table, you don't have a row for 49, so 50 is pretty damn close. But it's not because of this 50 here, it's because this 49 is close to 50. So if you look up t with 49 degrees of freedom and 5% in the upper tail, what you get is 1.676. 1.676. So our confidence interval will be slightly different. Slightly larger, I suppose. We're going to do 24 plus or minus 1.676 of these 1.41s. And that 1.676 times 1.41 we get is 2.37. So 24 minus 2.37 is 21.63. 24 plus 2.37 is 26.37. So there's our confidence interval. Pretty similar. A couple slight subtle differences in there. All right, this last problem. You can probably guess this would be a proportion problem because we did the other two types of confidence intervals. In a random sample of 100 Americans, we could figure out p hat, which is 12 out of these 100. In other words, 0.12. And we want a 95% confidence interval, so our alpha is 0.05. Shape. It's approximately normal. Why is it approximately normal? Because n times p times 1 minus p is greater than or equal to 10. Is that true? Yeah, that's true. N's large enough, 100, that'll make that work. Center is p hat, which is 12, our point estimate. Not 12, 0.12, 12%. And the spread, which is sigma sub p hat. Got a formula for that. It's p times 1 minus p divided by n square root of. So I guess I should punch that into a calculator. That was 0.03. Should I do one more decimal place? Fine, 0.032. Whatever. Okay. Picture. I want 95% in the middle. If 95% is in the middle, that means I have 2.5% in this tail. Z sub 0.025 is 1.96. So I can create my confidence interval by first checking the football score. Create my confidence interval, the center is 0.12 or 12%. Then I want to go up and down by 1.96 of these standard deviations. That is, I want to do 0.1, maybe I'll say equals 0.12 plus or minus my standard deviation times 1.96 is 0.064. Sure. Close enough? Close enough. Okay, so I got 12% plus or minus 6.4%. Gives me an interval from 5.6% all the way up to 18.4%. There's my confidence interval. That is the end of the quiz.